Hey guys, Mr. Verga here, coming to you straight from Mathland again. Hope you're having a great day. Today we're going to talk about something a little bit different. Today we're talking about congruent triangles. How can we tell if two triangles are the same? How can we tell if they have the same side lengths and the same angles? Now you guys might have done something like this in the past, and you might have used some theorems like side, 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 or side, angle, side, or angle, angle, side, something like that. But today we're going to take a geometric approach to see if we can see if two triangles are congruent. We're going to take what we've learned and what we've been working on with transformations, rigid transformations specifically, to prove that triangles are either congruent or they're not. So we're going to start with our grid, right? We've got our X and our Y axis, and we're just going to start by putting 3 points on this grid and draw the triangle. So I'm just going to put 3 points. It can be any 3 points. And I'm just going to do these. And then I'm going to connect my 3 points and construct my triangle. Now, so that I can keep up with corresponding parts, I'm going to put labels. So let's call that guy A. Let's call this guy B. And C is going to be right there. All right, so the general idea is that if I do a rigid transformation, remember that's a translation, a rotation, or a reflection on this triangle right here, I'm going to end up with a congruent triangle because rigid transformations maintain both the shape and the size of my original figure, right? So to illustrate that, I've got some transparency paper here, but you can do this with some really thin paper or some clear paper, and you can try this by yourself, right? So I'm gonna take this and I'm gonna lay my transparency over it, and I'm just gonna trace my original image. Remember, we call this the pre-image, onto my transparency just like that. Try to get it as good as you can. And then of course on my transparency, since this is the after image, I'm going to mark it A prime, B prime, and C prime, just like that. Now, if I wanted to do a translation, AKA a slide, I can move to the right, I can move down, I can move to the left, I can move up, and no matter what I do, I'm going to end with two congruent triangles, because a slide or a translation is a rigid transformation. I'm maintaining that size and shape of my image, or of my pre-image rather, to get my image. Just going to clean this up a little bit. Perfect. So a translation definitely maintains congruence. Let's see, what about a rotation, right? So if I take this and I rotate it, and I'm going to rotate it around any point, it doesn't matter. So I'm going to put my finger here and rotate it 90 degrees. And we can see that even though this is pointing in a different direction now, it's still congruent to my pre-image. If I rotate it back, do the other side, I'm going to get back to where I started. So, what about a reflection, that third rigid transformation that we know? Well, this gets a little tricky, but let's say I wanted to reflect across this line y equals 0, aka the x-axis, right? Now, I'm not going to put a crease in mine, but if I wanted to, I could go down here and see that, hey, indeed, I get a congruent triangle. So how do we use this to prove that two triangles are congruent? Well, if I start with two triangles, let's get another one going. If I start with two triangles, so I'm just going to draw another one here. And the question is, hey, are these two triangles congruent? Well, you can use your paper here, your tracing, and ask yourself, is there any set of rigid transformations that I could do to get this guy down to here and match up perfectly. Well, you guys might be able to look at this right now and say, well, yeah, Mr. Virgo, of course there is, right? So let's see what I could do. I could slide this over to the right. And then I could reflect this across the x-axis. And boom, I lined up on top. What does that tell me about these two triangles? Yeah, they're congruent because I could get from one to the other through a set of rigid transformations. Is that the only set of rigid transformations that maps this guy onto that one? Nah, there's a ton. What if I wanted to shift to the right like I did and then shift down? And then maybe I wanted to rotate around this point A. That gets me there. Congruent triangle, right? What if I wanted to shift it down here and then reflect it across this line, y equals -2? That gets me there. All right, what if I wanted to start at the beginning and go down first to here and then slide over to there and then rotate in the middle here? That gets me there. Does it matter which order or which types of transformations that I use? Not as long as they're rigid transformations. So we can see that if one triangle can get mapped exactly onto the other one through any set and any number of rigid transformations, then we can say that they're congruent triangles because rigid transformations maintain size and shape. And that is the definition of congruence. Same shape, same size. All right, guys, have fun trying this for yourself, and I'll see you next time. Have a great day.